I've got two tables here. These are the blue tables. On top of each one of these tables is a 5 kilogram mass. These tables are frictionless surface, so the object can slide freely. We've got a rope attached, and the rope goes over a pulley. These pulleys are special pulleys that I bought at the Lowell Physics store in Diagon Alley, and they are massless and frictionless. Alright, in the left case, what I have is I've got a pulling force, so I'm pulling this down with a constant pulling force of 20 newtons. On the right side, I have a 2 kilogram mass attached to the rope, and of course that 2 kilogram mass, if you multiply it by gravity, is 2 times 10 is 20 newtons. So I've got a 20 newton pulling force here that I'm pulling down with my hand, and over here I have a 20 newton force being pulled by a 2 kilogram mass. My question is, which one of these two situations will the object, the 5 kilogram mass, reach the pulley first? So I've got the 5 kilogram object will slide across to the right in both cases. One is being pulled down with a 20 newton force by my hand, another one's by a 20 newton force by way of this 2 kilogram mass tied to the string. So pretty easy question, as usual. So which one reaches first? Is it the left block? Does that reach first to the pulley? Does the right block make it to the pulley first? Or is it a tie? Are they the same exact situation? Alright. If there's any other situation you'd like to consider, you can go ahead and vote for number 4. Alright. A couple things to think about as you do this is, first of all, can you assume the tension in the rope is constant throughout? And of course, that's what the whole purpose of having this massless, frictionless pulley is. If we have no friction in this pulley, then the tension will be constant. It turns out we also need to be massless, and I'll talk about massless, what the massless versus mass pulley means to you in class. Alright, here's another opportunity for you to vote. What I have is I've got a massless frictionless pulley in green. I've got a rope hanging over it, and the rope is massless as well. And I've got two masses tied to either end of this rope. Alright, the question is, what will happen to this little system if, in the first case, if the two masses equal each other? Alright, if mass 1 equals mass 2, for example, let's say I have a kilogram for capital M and a kilogram for little m. What would the system be doing, or what could the system be doing? Well, the first case, I guess we could consider maybe the system's doing nothing. Is it in static equilibrium? The second case to consider, perhaps this is in a constant velocity situation. It's dynamic equilibrium. The third case is, well, what if this, is this system possibly accelerating with no equilibrium? Vote number 4 if you think that it could be number 1 or number 2. Vote number 5 if you think it could be number 1, 2, or 3. And if you have another option, you can pick that, but you have to come up with an explanation. All right, and that's all I have here for this first voting opportunity. Is I've got two masses hanging. There's no other external forces interacting, and the question is, what could be happening here? All right, vote 1 through 6. The second case is, what if we actually make one mass larger than the other? For example, let's say that the capital M is 1 kilogram and the small m is half a kilogram. What would happen in that case? All right, well, we've got an imbalanced situation certainly here. So would we be accelerating at free fall rates again at g meters per second square? And I guess which way would the pulley be rotating, to the clockwise rotation or counterclockwise rotation? Would the acceleration of the objects be less than gravitational acceleration? Or would the acceleration be greater than the acceleration due to gravity? And if you have another option, well, you explain what it is and you can pick number 4. All right, take a moment to vote on those two options.